In this video, we're going to look at the big decimal class. Now, as we've seen in other videos, floating point is not an accurate way to represent numbers, especially if you're going to be comparing them. There's some workarounds you can do with using different precision type things to get it to work out, but really in the end you're going to lose precision, and it just has to do with the way that floating point numbers are stored internally. They're actually converted into binary numbers and stored that way, and when those conversions happen, you'll see accuracy loss. Now, I'm looking at the online at rubydoc.org for the library RDoc for big decimal, and they have a nice example down here of where it doesn't work. So here's this good example. So here you have two floating point numbers, well actually three. So you have 1.2 minus 1.0, and you're comparing them. Are they equal to 0.2? Well, they should be, but this is going to return false. And we can even check this out if you want to make sure. Let's do this. There you go. It turns out that, you know, the way these are stored internally, you lose accuracy, and they end up, whatever the value of this is, not the same as this. It might print out the same to you, to the screen, but that's essentially a string representation. Internally in binary, though, they're slightly different, and that leads to inaccuracies that can build up very quickly. And then, you know, if you're doing it with cache or something, boy, that can make big problems when you have some inaccurate cache values. So a way around that is this big decimal library. Now, how it actually stores the numbers is as strings. So instead of taking numbers and converting them into the binary form of that number, in other words, if you have 8, you'd have 1000 inside the memory if you could look at it. Instead, you're storing, if you put in 101, say 101, you would have the actual ASCII or Unicode values of 101 stored in memory. So that gets you the accuracy. What you lose, however, is speed, because now, typically those numbers are represented in Unicode by pretty big digit or pretty large quantities for a single character. So you're going to lose a lot of performance, but you gain all that accuracy because you'll keep on having all the numbers represented. And of course, if it's an irrational number, you can't really deal with that. And there's actually a rational library here that Ruby has to deal with those as well. So with big decimal here, if we go back here, if we do this one, I'll just copy and paste that, and hopefully it works. The copy and paste, I knew the code would work. You'll see that we convert these into big decimals and run them through the math, and then they work out fine. They come back saying it's true, and again, it's because they're represented as strings. Now, if we look over here at the method, you'll see that it pretty much does any type of operation that other numbers do, and we can scroll down to the bottom here and see it as well. Here, let me find all those symbol type operators. Usually they're listed. Here we go. And so we can see we have all the typical ones that fixed num and floating point have. So it's really a nice way if you need to deal with really big numbers and keep accuracy. The one additional thing I wanted to point out, there's other classes in here that are more advanced, and it does some pretty sophisticated stuff with regards to math if you're really into math kind of stuff. But the big math has some common methods that you might want to have. Say you're doing college physics or something and you want to do some stuff in Ruby and you need a little more accuracy than you normally would have, you can use this big decimal class to get that accuracy. So we have e and pi, which although they appear as constants, they're actually methods, and you can see here they're public instance methods, and it computes the value of e and pi to whatever you want. So let me show you how you do that real quick here. So in order to use the big decimal thing here, I have some code already in here, but you have to require big decimal, then you have to require big decimal /math, and then this last kind of odd step that you might not know about, but I'm telling you right now, is to do this include big math. So you wouldn't put these at the beginning of your code. Then at that point you can get these different values. So if we want to get e to the 20th significant digit, I can just do that, and there I have e spit out, and I could do whatever I want with it. I can also do pi to the 20th, or let's get silly here, see how far we can go out. There's 2,000 digits of pi. So it's a pretty cool library to do some various things, but probably the other functions you'd be interested in are the log function and these trig functions that are available. And you would use them the same type of way that you use the other functions, where you have a number and you call it as a method. So that's the big decimal class in Ruby.